to our class for today. We are taking basic science in our class for today, and today we're going to talk about power. Remember, in our previous class we discussed the topic on potential energy and kinetic energy. If you have not watched the video, please navigate and watch the video. I'll put the link below this video so that you can watch that class. Welcome to our class for today. If you are a new subscriber, thank you. If you're a returning subscriber, welcome. Thank you for always dropping by. Then if you're new to the channel and you have not subscribed, please click the subscribe button so that you get notified anytime we upload a new video. If you know of those who can benefit from this class, you can invite them in. So welcome to the class. Today we are going to talk about power. We have discussed power, but today we are going to see how we will apply this formula in our equation. But remember that I told you that power is the rate at which work is done. The ratio of the amount of work done and the time it takes to do the work. Power, it's the rate at which a particular work is done. And it equally tells us the ratio, the time it takes to accomplish that work. That is power. From our explanation of energy, power, and work. It was 2 classes away before we took potential and kinetic energy. I'll still put the video below, the link to the video below this video, so you can watch them from the very beginning, then potential and kinetic energy, and then this. So today we are going to see how we can apply this formula. This is the formula we use in calculating the work done, the amount of time it takes to accomplish a particular work. Now, what is the formula? The formula to power is work done over time. Work done divided by time. Now let's try to use this triangle to explain it. W, P times T, which is the time, the power times the time. Now, what does each of these symbolize as we impute them in our formula? W is work done, which is measured in joule. P is power, which is measured in watts. And then T is time, which is measured in seconds. Please remember what this symbol stands for, because we are going to use it in our formula. Remember that work done is measured in joule. I told you that when I explained energy, work, and power. And here I am telling you right now that power is measured in watts. That's why in our, the electric bulb we use in our house, it's measured in watts. You said 60 watts, 120 watts, 100 watts, because power is measured in watts. Then time. The time it takes to accomplish the work is measured in seconds. Alright, now let's use an example to portray this formula. We'll take a few examples, about 2 or 3 examples. Now this is the example that I want to use here. A car reached its top speed from rest in 7.5 seconds, which is the time. It is able to perform 250 joule, that is work. In that time, how much power does this car have in that time? How much power does this car have in that time? Now let's impute this into our formula. Now we said the formula is work done, which is this, divided by time. The work done here is 250,000 joule. This is the work done. This is our work done. Then time. Now this is our time, which is 7.5 seconds. If you wish, you can put the seconds like this. By the time we divide 250 work done over time, which is the second spent, we are going to have about 5 threes, a lot of threes, then we take to the nearest decimal. So we are going to have 3, 3, 3, 3, 3.3. Since it's 3 in infinity, we're not going to approximate because it's not up to 5, so we take the 3 down and take within the next. So we have 1, 2, 3, 4, 5.3. This is the amount of time, this question here, which is how much power does this car have in that time? The amount of power it has at this time is 33,333.3 power. That is what we have. So we see we have imputed this question into our formula. So the question says a car reached its top speed from rest in 7.5 seconds. It is able to perform 250 work, which is measured in joule. So this is our seconds, this is our joule, this is work done. This is our second, which is time. You put this into the formula, work done divided by the number of seconds, and you will have, does this car have in that time? This is the power, 33333.3. It's the amount of power that car have at that particular time. Let's use another example to answer another question and input it in the formula. Then I will give you one to go try on your phone. Now let's look at example 2. We've taken example 1, example 2.0. The other one we took was example 1.0. A motor car transfers 500 joule of electrical energy into gravitational potential energy in 40 seconds. Calculate the watts. Calculate the watts. The watts, W, which is measured in power. Remember the formula, work done divided by time. Let this not confuse you. It said a motor car transferred 500 joule of electrical energy. This transfer, that means it is the work that is done. And remember, work is it's measured in joule. And so a motor car have transferred 500 joule of electrical energy into gravitational potential energy in 40 seconds. Now let's go to our formula. Remember that I told you that power equals to work done. Let me take it this divided by time. This is work done. Now, the transfer of energy, it's 500 joule. So you have is equals to 500 joule, which is the work done. Now it says converted it into gravitational potential energy in 40 seconds. And our formula T here is in seconds, measures in seconds. And so 40 seconds. So we say 40. Now if you divide 500 divided by 40, what will you have? You are going to have 12.5 watts. Remember I said calculate the watts. So this question is just telling us that a motor car transfers 500 joule of electrical energy into gravitational potential energy in 40 seconds. Just calculate the watts. How do we do it? Go to your formula. Remember what we are doing in our class today is applying the formula of power. What is the formula of power? Power is equals to work done divided by time. The work done is measured in joule, which is the work done. It's measured in joule. The power is measured in watts. Why the time is measured in seconds? You just come to the question. The work done is 500 joule. The seconds it takes to accomplish that is 40 seconds. By the time you want to calculate it, divide it and have your power in watts, which is 12.5 watts. It's as simple as that. So we've been able to use two examples to apply our formula on work. I know if you lay your hands on any question, you will be able to solve any of this question. I'm going to give you one example on the board, and then you go try it out. I'll give you the final answer, but you will go and try it out. It's going to be assignments. Let's take that. This is the assignment. A motor car transfers 600 joules of electrical energy into gravitational potential energy in 50 seconds. Calculate the watts. Just go to your formula, power, which is work done divided by time. Put your questions into the formula. Your final answer is going to be 12. If you have 12 as your answer, you are correct. So please do these assignments. It's just an introduction to power and application of the formula. So we've been able to master the formula. Remember, W is work done measured in joule. E is power measured in watts. And then T is time measured in seconds. If you're able to know this, you'll be able to put them back into your equation. And remember that power is equal to work done divided by the time. Know what the work done is. Then know your time, then divide and get your watts. I hope you find value for the class. Thank you for coming by. We will take another part on this series. So please navigate through the channel and follow along as we take them. This is part 3 of this class. If you've not been following through, please follow through. I will link the other 2 videos below this video. Please do your assignment. This is an assignment. I have just simplified it for you. Just go try your hands. It's an elementary part of it. Thank you for dropping by. Thank you for being my community. I will always show up as much